Hi guys. Okay, I don't need to tell you who I am by this time, so let's get right into it. Okay, in this episode of Mapping on the Fly, which is a homage to my bud's uh, uh, um, video blog, I guess you might want to call it, called Modeling on the Fly, and a person we all know and love in the persona of Zach Parrish, which he used to spend at least an hour just showing awesome modeling techniques based on a project. So that's the kind of the route we're going with. We're showing the broader concept rather than focusing on just one tutorial of how to do something. So in this episode, we're going to be dealing with how to make use of collision in a productive manner. In other words, not just show you just what the simplicity of what a collision mesh is as to a typical object construction. In other words, you're making a map object, and the map object needs collision. So here is the tutorial on how to do that. And then by extension, you use that technique to cover other areas like walls and what have you, as far as component building goes. But in this case, what I'm demonstrating here is a process that I like to refer to as edit in place, because how I edit in 3ds Max is how it translates over into Unreal 4 as a one-to-one match. And then all we have to worry about is creating connectivity between the two. You know, Epic's working on a thing called live update, so it'd be interesting to see if they do live update for environment development. Right now it seems to be limited rather to animation. But to do the atypical tutorial, we can cover that pretty fast by just building a box. Okay, we'll call this house. So H-O-U-S-E. Okay, so so we have our house built, or an object. This could be a trash can or a mailbox or whatever. And usually to create the collision for it, this is a simplified geometry. We'll create a copy of this and call it UCX. Whoops, UCX HOUSE. I think capitalization matters, but we're not going to worry about it because we're not going to be doing anything with this. Oops, actually I created that as a relationship constraint. Okay, house with capitalization. Let's do this again. All I'm doing is scaling up, and we're going to call this UCX underscore HOUSE. And now ta-da, our object has collision on it when we export it, as it's wrapped around this object too as well. We'll do maybe a extended version of this technique for building a collision for map objects when we get to doing actual map objects for our environment here. We might have to do something fancy for a vehicle or something like that to get proper coverage. But that's basically it. If we now export this over to Unreal 4, the collision mesh, this object here, disappears, and that leaves us with this object here, which if we run into, we collide. But we're going to change up the concept here a little bit by using a more, I wouldn't say advanced collision. Collision is collision. What we're going to do here is a much more slicker approach to collision based on a simple idea. The idea here of collision is to more or less keep the player inside the map, so they're not falling through holes or whatever as they collide with a surface. And we're going to start with something simple by displaying the concept of what we're going to be doing here, using this simple plain object as it stands. If I go ahead and select the properties, and we're going to turn on backface call, we have no back surface and we have a front surface. So with that object, I already exported it over to Unreal 4, so we just have to go over to Unreal 4 and test block. Okay, there's our test block. I think this has also been edited in place, so exactly where, just to kind of fall through with the notion of edit in place, we place our object in 3D space. It's not there until we go over to our transforms, and we can see where the location is. We hit the the go button here, and there is our object plane that we're going to use for our collision test in 3D space. Now I already have this set up for third person from our last episode still, and this is where having just the ability to run around a map comes in that we can run through our wall, and there's no collision taking place. But we have the cheaters, usually referred to as the cheater collision, is changing the collision default from project default to use complex collision as simple. Now this is great because you can load in a whole bunch of geometry and quickly set up collision for all the objects in a single go as a matrix, a matrix change to the all of the objects in one at the same time. But now if we hit play, boom, we're bumping into the collision mesh. If we go around the back, and we can walk through the collision, so there's only collision on the front face but nothing on the back. So what does this tell us? This tells us that we have a one-to-one correlation of a collision object as to the amount of surface that is applied to it. So in this case, when this is like auto collisioned, this is made up of two triangles on a single surface, and that means that two surfaces will have collision applied to it automatically. I believe that's how it's done in Radiant anyways, and anybody that knows that you can set a flag that sets up per surface automatic collision, but of course the amount of detail that is applied to it adds significantly to the number of surfaces. Now I can tell you for a fact from experience that collision is a performance hog. In other words, if you have too much, it can impact your overall performance of your map for the fact that a lot of stuff may have redundant collision that is not really necessary. For example, in Abbey, I have a pub sort of to one side that's been kind of replaced a wall that used to be just a simple wall surface into an area that people can look at and into it as a visual impact. Since geometry is cheap as far as performance goes, as there's nothing really applied to it except for what you apply to it after the fact, like materials and what have you, which is what adds to whatever performance loss that you may experience. But as it turns out, every little map object that was in that area there had collision applied to it, an actual UCX collision, and after I removed, I was kind of looking into it one day and I said, oh boy, we don't need that because nobody's going to be able to go in that area. So I went ahead and wiped out all of the collision, and after that experience I did the same thing to the entire map by removing all of the collision and then reapplying it in a controlled manner. So it became easier to control and a lot more efficient. Now, to give credit where credit is due, the next step is to actually hide this. And that's just simple enough that we can go down here, somewhere in here is a visibility rendering. Okay, if we uncheck visibility, our wall disappears. We hit the play button, but the object is still there, and we have collision. If we go around the back end of it, we can still run through the back end of it. So we're only applying, once again, collision to the front surface of it, and not the entire object, as it would be if it was like a UCX box or even a blocking volume, for example. So if we're looking for the ultimate in low resolution type of solution, then this has a lot of ability to change it up. So we can, let's get rid of that now, that we can shape our bounds, our outer limits of the map, so that we can keep the player inside the playing area as it is designed to do. Okay, so anyways, where this idea came from was originally when I was doing some mapping stuff in Radiant, and I was sort of sandbagging along a discussion that Blade Killer and 27 were having about substituting geometry for brushes and the efficiency as well as the added performance that getting away from brushes provided. And I kind of tested it out on a map. I think it's still up on the YouTube's called Grand Hall, and I used every last stick of available construction memory, which is I think something like 500K or something. I maxed it out with high detailed modeling, and I converted it in 100% geometry, and then applied per surface collision, and lo and behold, it did what what was exactly what was discussed. You know, the efficiency went up, the performance went up. It was actually a faster map, considering the amount of geometry that was visible at any given time. And so I've just sort of carried that on over into Unreal 4 once I figured out how exactly collision was supposed to work in this type of situation. So what does that mean? Mean from rambling on, etc., is this is our collision on the outer face of this building that prevents players from kind of running into this, into the wall and into the environment. Remember, back facing is showing towards the player. People can run through, but they can't run back through the other way. You know, that has some interesting possibilities, which I probably won't get into. Now, I didn't finish this off to any extent, because I'm going to finish it off in real time, showing you some modeling techniques. I do not want to turn these into modeling tutorials, because the same system that I'm using here, it can be used in any kind of editing application that can generate back-faced objects like a planar object. So I'm going to actually finish this off in real time to show you how simple this is. I also didn't do the interiors of the buildings just yet, because we need a collision surface that's facing into the building, because I'm going to cover that when we're doing facade work, because it's a process you can do at the same time to decrease the amount of collision information that you need. So the fabrication of the facade is actually what we're going to be using to create the base for the collision mesh. Less work, but to kind of demonstrate how fast and easy this is, we'll do a little bit of modeling by selecting our geometry here. I'll select my edge selection tool and select the edge. And we'll see just how quick this is. Make sure I got everything. Let's see how quick I can do this. Okay, so you're going to scoot this along. Oh, by the way, it's transparent because I created a transparent modeling texture that is animated, so I can, by increase or decreasing it. So all this does is keyframe the opacity, so it goes from 100 to 0, so I can slide this back and forth. So if I need to see behind it, then that's quite simple to do. Now, along the way, you're going to deal with insets like this. We're actually set up right at the moment to deal with that, which, as I said, I don't want to deal with creating a modeling tutorial, but we'll stop our edge forward momentum at this point, and we'll move that along, and then we'll move that along again till we get to the end. And then just to kind of show you what, usually I do this as a secondary process. Go, like all the doors, as you can see here, are knocked out to allow entry into the building. Usually that kind of stuff I leave until I have the surface in place, and then go back and do the knockouts. But just to kind of show you a tool we can use here, we can select the extrude tool, extrude that inwards. I need to go to perspective view so I don't get messed up by the orthographic. Now, the first thing you usually come across, the first impulse is to make everything kind of skin tightish, which you're going to be wasting a lot of time. It's best practice to just kind of rough everything in so that it fits. I'm not going to worry about loop alignment, because we're not going to be worried about doing any texturing. And there's actually a ground on that was created through the extrusion. I'm going to delete that because we're going to use the ground itself to extend into this area. Now we have a proper enclave, or whatever you want to call it, inset where the player can just kind of deke into for coverage, maybe. I don't know. It's there though, and it's accurate. And then I'm going to kind of bring that over just a tad and bring that back. Now this is where this type of detail comes in handy, because we're between the outer surface of the detail in the wall. That's actually pretty nice and tight for what we need. And then I'll kind of freehand it up, and then continue on. And we have a little bit of a hitch. Yeah, you know, I don't know if that's going to be, it's like you can see around that corner. But you know, it's we'll just keep in mind that we might have to put a little bit more detail in that area so it doesn't look like it's a go nowhere zone. And we'll bring that over to there. Whoops. And all the time trying to talk to fill in dead air. I don't think we need to do it too much though. You know, I could have probably got this halfway around and turned this into a 5-minute video. Okay. Okay, we got kind of a zigzag here. A little bit of a zigzag. I want to keep the alignment, say, with the fence. Okay. Yeah, there we go. Now we're still too tight. Still a weird, you know, I think I'm going to do the fence as a collision object. And we're just going to bring this all the way to the building. Yes, and this is how modeling on the fly usually resulted in some dead air. But, you know, Zach's a rather entertaining person, so always had something to say. Superior presentation skills. Okay, now we got a little bit of a door opening here to contend with. So we stop at the door edge. I have these loops already set up from the doors and on the other side that needed to be hacked out. And then we'll just continue on. Now, if you're using 3ds Max, all I am doing is grabbing the edge and then press Shift and drag. And it drags out a copy of the edge itself, which creates the plane. Then you select that. And we can see, okay, we got a bit of an issue here because, you know, this is an area that a player will jump into. So we need that back, and I'm going to use a quick connect. And I'm not going to worry about maintaining best practice ethics as far as looping all the way around, because we're not, you know, this will never see the light of day once it's made invisible. It's to keep the player inside the map and made invisible. So now, if I didn't have to talk and I wanted to get this entire job done, I could probably get it done in about, I would say, cleanly in about an hour and a half to 2 hours, including the interiors of the buildings, because it's just straight up plain Jane everyday box modeling. And if you have excellent box modeling skills, even in Blender, it becomes a very fast process of being able to create the collision. Now I'm doing collision now because it is a rather important as we move along, as something that doesn't have to be done right away. It could be deferred to whenever you want. You could do it as you work, or you could leave it as a finalization process, which does have some benefits in efficiency as well as maintaining performance, because the geometry that you're putting into place for collision is what is needed for the collision. It's not something that is added arbitrarily. Like if it's a decision between, I purchase a fair amount of ready-made assets, because not just because I want to use it for actually creating the environment, but rather to have access to the parts so I can bring it into 3ds Max and make it fit exactly 100% to what it is I'm working on as part of the construction process. So, they got some lovely trim pieces and some nice building options. But what I don't want to do is, have 4 trims across this section here for the crown of the building, as opposed to having one, which I can model that in. And it pays off in dividends when you start to actually applying your lighting and what have you. The lighting plays entirely different when things are sealed off and doesn't have any open edges to deal with than it would be if you were to build the same environment, or the same kind of construction using component objects. Like this little section here would probably be about, let's see, maybe 4 different components. Granted, we get the benefit of instance models, meaning that the one model, a copy of a model in Unreal 4 is the same thing as having just one. Let me start that over again. Having 10 models based off of a single model is like having just one model as far as overall impact and performance goes. So that it would probably include things like oh man, lost a train of thought. I cannot create collision mesh and chew gum at the same time. Okay, we have a little bit of an inset there. We want to keep things a little as accurate as possible, I guess. It's also, instead of going back and doing it later, if we do it now, it's easier to find the gap, so to speak. Extrude. Speaking of modeling on the fly, I think there's some of the stuff that he had that was put in there for ages is still available on 3D Buzz as a free access video. So if you're into 3ds Max or Maya, I think there might be some Blender stuff up there. I learned a lot of little tricks that I would never have considered making use of until they're shown to you. Like, that's why I'm kind of doing this live, taking the time to do this instead of doing a 5-minute video. I personally find it more informative to actually watch grass grow from time to time, pick up and watch somebody do what they're doing, do the thing that they do so well, than it is to just have them tell me in the grand scheme of things of how things kind of work as a tutorial. It might be something to consider for somebody that's interested in coming up with an idea to be a little bit showy as to their skills. If you're into object making, do a video showing the process from beginning to end. Might take normally, without all the chatter and all the who's and what's and wherefores, could probably take you as little time as possible to finish off the project than it would be to actually let people follow along. But I'll tell you, I kind of go out and look for these types of videos, the how-tos, like I would say call it the Adam Savage technique for showing off stuff is to show the process. Also showing the screw-ups. I mean, everybody kind of at some point kind of assumes that what was done first time. That they took the one. It took me about 6 months to figure out I could do it this way, and then once I figured that out, I can pretty well box in the necessary collision in at least, well, on a map this complex, whoopee, I could probably do this in a couple of, as I said, in a couple of hours. You know, the setup part, because I didn't want to, it had some unusual detailing, some curves and angles that needed some a little bit more attention to the detailing. And once I get to the other end, I'll probably display it. Now, I got a bit of a decision here. Do I want to be fussy? You know, I can always remove the this cornering piece at a later date. Because this fence here, I could see, this is where we're going also get a little bit of a bonus is as I mentioned, when you buy ready-made assets, they're usually, collision is usually applied based on the assumption that they're going to use it as is in place in Unreal 4, as opposed to having it as an edit piece added on and doing your own collision later on. So we have probably on this mesh maybe 24 collision elements, including the what will be the chain link fence. So in this case, we covered our needs with just a single. Could cover the entire plane with a single collision object that's based on 2 triangles. So our performance envelope right there, just right there, is maximized. I mean, it doesn't get any better than that, period. And of course, here's a huge amount of saving in collision information. We just cover this entire strip here with, well, actually we got a division in the paneling here. What we can do later on is, once we're happy with everything that's in place, we can go back and actually remove edges, because who gives a, nobody's going to care if we have subdivided edges that are not continuous, which is usually a requirement of anal modelers as to the object creation, not necessarily the need to cover the area with some form of collision mesh. So okay, let's go around that corner a little bit more. You know, I'll save that for the back end when we actually get to the making of the facades as part of the cleanup of going around and cleaning out unused. We're going to look at this from maximizing the amount of surface being used for the single purpose of keeping players inside the map. Okay, so we'll go ahead and grab that. We'll grab that, we'll grab that, and we'll grab that, and we'll go ahead, hit the weld button, and we'll yard that up until, boom, see those two right there? They kind of sucked into one another at about 34 units, and ta-da! That's basically it. There's our collision mesh for our environment, to keep the player inside the map. As I mentioned, we still need to do the collision for inside the buildings, but that's going to be as part of the fabrication of the facade, to kind of give you an idea of the cleanup that we're going to be doing. What you do is you select the 2 edges, connecting edges. Actually, there's the connecting vertice. We select the 2 edges. We press Control and remove, and if we hit the vertice is cleanly removed. And we now had what we had as 3 surfaces. We now have 2, and we can get rid of this one, and then we have 1, and then we, which means that we just have 2 triangular surfaces as part of the collision. Now let's see if this actually does work. Do I need to do anything here? Nope. Okay, so it's continuous. It's one collision mesh that goes outside the entire building circumference and back in this way and this way. And we have some little nooks and crannies that are been edited into it. Did I do that down here? No, I didn't do down here. So let's toss that in. And we'll grab that face down there that we know is down there somewhere. Gun that off. we'll make the geometry a little bit more cleaner. Whoops. Yeah, okay, that's what we wanted, wasn't it? Okay, we don't have to be too picky about our edge looping or how tight it is, because we're going to see exactly what's going on once we get into game, and we can go when we get down to the final process is actually would be to run an evaluation on a map. What's the name of it? Boy, I forget. You know, basically what you do is you run the map, you record the information onto it, and based on the information that's feedback on that map, then it tells you what areas actually need the attention, and not anything that is discriminatory or not required during the process of actually making sure you maintain the old school way of efficiency, so to speak. You can defer a lot of stuff that has to be done, that used to have to be done in order when you were doing stuff in Radiant. Otherwise, you'd lose total track and control over your map. Okay, so we'll call this outer collision. And we'll just go, we'll continue the process of export selected, and here's my directory. I keep all my FBX source files into it. So what's this called? This is called I forgot. Outer collision. Hopefully I didn't screw up anything. So this will work first time and we don't have to mess around. Okay, where is my folder? My FBX folder. There it is. There's our collision. Okay, under this is going to be a primary build object, so I need to make I don't want to put that under reference, otherwise it's going to get lost in the bit bucket. So we'll go new folder, and we can change it later. Okay, this is probably one of the #1 problem with doing map making and stuff is figuring out where to put stuff. So that's what we're spending a lot of time and effort, is where to put the stuff. So we're going to put the stuff for now in collision mesh, and then later on when we do the cleanup as a cleanup function, we'll put those in proper directories where it makes a lot more sense. So there's my collision object. We'll drag that and drop it. Now we have some options here that we can take advantage of. For example, auto generate collision, and we might want to play with that at some date in the future. But as I say, we're going to be fine tuning this at a later date anyways. We do not need to generate UV mappings because it's not visible. Combine mesh, don't need that. Okay, go ahead, hit the import button, and auto collision generate has was rather uncommon. Doesn't matter to us because we're not dealing with any type of material work. I should have actually turned off import materials. And why are we still in play? Why are we not? Oh, there it is. So you can see that we're out of position since it was edited in place. We'll go ahead and snap that. Boom. And you can see we have no backface to it. And we can crash through the walls. And we can kind of skip around it a bit to kind of see where we're off. Okay, I don't like this. I want to hide. Okay, how the walls react to things like bullet impacts you need to keep in mind, because you know at some point we might want to push that back far enough so the surface would generate collision without having to make any kind of modifications to the collision nature. And I find that if you just kind of push it in behind the wall slightly, you get all the goodies that normally would go along with that, as if this was done as a singular mesh. But as a habit, as a workflow habit, I want everything to be a la natural. In other words, that they're the same process that has to take place is repetitive. We don't have a patch here that needs to be fixed, a patch there to need to be fixed. by making sure that everything is lined up to the outside of the wall. We can always go back and correct that by doing everything in order. Okay, so just a workflow thing. Okay, so you don't, doesn't matter if you want to line up everything perfect, then you're going to do a couple of sample areas, figure out what's going on, then go back and just repeat it through the entire mesh. The quest here is, the thing here is Unreal 4 has a natural tendency more towards modular design than it does for doing things that have to be done in order, that is atypical for Radiant. Okay, so there we have our mesh. Take a little bit more to tour around. Okay, I think it's what it's supposed to be. So with it selected, we're going to do our open it up thingy. There it is on our map. We're going to go down. This is, oh, so exciting. We'll see if we actually succeed or we fail. And we'll use complex collision as simple. The amount of geometry used is actually slightly, as explained, is slightly higher than it would normally be. But we're going to do that, and during the cleanup process, we're going to get rid of all the extra edges that we don't need. Ideally, we're going to get it down to as little as possible. But as you can see, we have collision. I can't run into through the wall. We have collision. Ladies and gentlemen, we have collision. We have our little nooks to hide into. We have the back wall done. Anywhere you see blue is collision. We have collision there. Oh, we have a doorway there. So we're going to run into it and of course fall through the floor. Because we don't have collision on the inside of the building, which, as I said, we'll do during the facade part of this procedure. Now, we have a geometry that we can turn on and off as to visibility to see, if there's any correction, and we can double, triple, and quadruple check. We do obviously have some features built into Unreal 4 which will allow us to turn on the collision so we can see exactly if we're filling up the area. But once we're happy, we can select that and we can just go, as I demonstrated, we go down and we go find our rendering and we turn off visibility, and ta-da! We have collision. And you were there, you saw me make it. I did. there was nothing fancy. Yeah, see, you can see down the back end of the and of course there's no door there. Okay, let's cover one more idea, one more concept. Now, what makes an Unreal map Unreal map? What makes an urban terrain map an urban terrain map? Well, I would say that the one thing that makes this suitable for playing in urban terrain is vertical collision, meaning that the walls are, the collision is per surface area as to an area that needs to be blocked. So this will be easier. If we're running down the wall here and we're running kind of semi-sideways, and each of these items here, like the bricking the elements here, had collision applied to them as well, it would create a collision element that sticks out horizontally to the vertical collision. So if somebody's trying to jump this wall, they're going to get hooked up on the collision and they're just not going to be able to complete the jump. So as demonstrated, you saw how all my walls are vertical to the ground, all the way around, 360 degrees all the way around, and the same thing will apply on the interiors. So at no point or anywhere within this map is the player going to get hooked up on horizontal collision. But you're going to have things like this element here that sticks out into the playing field, which kind of should have collision on to apply to it, but we don't need anything exaggerated. Now, when I start actually doing the map objects, this is a map object. Once I start doing this, then I'll, probably put UCX collision onto it. But just to kind of to demonstrate an option is a collision volume, a blocking volume. Now, blocking volume is just that. It blocks. Okay, so we need to go G to show it. Then we need to kind of fit it around. Because I don't know what this booth is may be used for, as it would impact jumping. Remember, we're building this map to somebody else's requirements, and not necessarily ours as to what we would like. That's what got me into trouble. I did a version of Turnpike based on what I wanted to do without due consideration of what it needed to do. So there we have collision. Okay, by using a blocking volume. Okay, guys, I think that would cover that. Doing this process in Patchwork, though, does give me an opportunity to catch up to anything that I might have missed, that I feel that I need to jam in at the last minute. So I'm going to call this one completed. We have now have the ability to run around this map and not fall out of it. That's pretty cool, eh? What was that? About 20 minutes worth of work? You throw in another 20 minutes for, or I would say, was it 10, 20 minutes? No, it must have been about 15, 20 minutes, yeah, to do the prefab of this building section here, because there was this door here to deal with, doors around here to deal with, and we're going to go all, it'd be faster if I did this. And then we have like this little nook here that hooks off from the rest of the surface here. The player has to be able to go up into this area and then run around here, but not run out of the map or jump up top there. We'll put something up there to along the edge to kind of hint at the fact that you cannot get up there. Also, because it's edible, like it's not hidden like or attached to an object. If we wanted to, we can easily go back and reconfigure our collision in a matter of hours, if that. I mean, if we say, okay, we want the players to run across the top of the fence here, okay, and so that's about, I don't know, a 10-minute fix at that. So anyways, I hope that you found this informative, and I hope this isn't too long. And we'll stop rambling, and we'll get on to the next one. Next episode. Okay, let's talk about that a little bit. What should we do in the next episode? We can sort of jump ahead a bit and talk about material work, or focus on. I think in the next one we're going to be doing facade work. That is actually. The facade work is usually the first thing I do, not the fourth or the fifth or the last thing I do. It's just that progression-wise, it makes sense to do it in this order rather than doing it the way I usually do. Okay, anyways, we're rambling. Talk to you guys later. See ya.